Hi all, and thank you for joining the session. Like Patrick mentioned, my name is Saad Malik. I'm the CTO and co-founder at Spectro Cloud. And so today we'll talk about the next phase of Kubernetes management, specifically looking at declarative management and how to do so with Cluster API. Next slide. Okay, so a little bit more about myself. I'm the guy who likes to build and tinker with new technologies, especially in the areas of Linux, virtualization, containers. I was part of an early cloud startup called Clicker Technologies, where we focus on multi-cloud application management. And that is actually where we first started working with Docker containers and container orchestration platforms like Apache Mesos, and then the early versions of Kubernetes. So Clicker was acquired by Cisco in 2016. And then we started seeing firsthand just how quickly the world was changing, where organizations and enterprises across all verticals were transforming themselves to become technology-first companies and to offer best-in-class experiences to their customers, their employees, either via applications or other digital mediums. So with this, of course, came a significant mindset shift, as companies started adopting a DevOps culture and embracing these cloud-native technologies like containers, Kubernetes. So in 2019, along with other key executives from Clicker Technologies, we left to start Spectro Cloud to really focus on making Kubernetes accessible and approachable to everyone. So let's take a step back and see where are we today with the Kubernetes adoption. Right, as all of you guys know, Kubernetes has become that de facto standard in running containers. It's become that common control plane, that common operating system that not only helps you build your application, but also helps you manage your application. And what we're finding is that not only are containers and Kubernetes usage and adoption increasing, but it is also accelerating. In fact, we at Spectro Cloud sponsored a research from an independent company called Dimensional Data to interview 160 or so Kubernetes practitioners and their executives. And the findings actually validate that the growing number of Kubernetes clusters, and more importantly, that many of these practitioners of Kubernetes are deploying many more clusters into production very soon. So why is that? Well, if you take a look at the promise of Kubernetes from its get-go, it promised a very robust and scalable container orchestration platform with promises of true portability of your workloads, and at the same time, being able to help drive your efficiencies. It was meant to be the holy nirvana. Unfortunate truth is, and the hard reality is, that Kubernetes really hasn't lived up to its expectations. And I'll talk a little bit more about some of the reasons why I think that's the case. So first of all, when we talk about Kubernetes, it's not just one thing. When we look at Kubernetes, we're talking about cobbling together hundreds of different integrations across the entire ecosystem. Today in the CNCF landscapes, there are over 1,700 different technologies across many different layers. And it's not just about managing each integration's lifecycle, but also making sure that these integrations play nice with each other. So Kubernetes, technically, if you think about it, is just a piece of software. It's the control plane components like the etcd, the API server, the scheduler, and an agent called a kubelet, which runs on the worker nodes. If you ask the actual industry, you ask the vendors, they'll tell you that Kubernetes itself is 4 different layers: the operating system, the Kubernetes itself, the networking layer, and the storage layers. But what I believe, and we believe, is that the reality is that Kubernetes is the total value and experience that a complete Kubernetes provides. This is what your developers think of with Kubernetes when everything is deployed inside of it. So this, by the way, is a quick screenshot of our product, Spectro Cloud Palette, and that's a real stack. On average, we find that customers deploy 12 to 15 different integrations which belong in any one cluster. Everything from your logging, your monitoring, Ingress, security, cert manager, you name it. There's just so many different layers of technologies that you have to add into a Kubernetes cluster to make it real. So let's talk about Kubernetes management. There are 2 different groups. There are the DevOps and IT Ops, mainly, I'm assuming most of your team and your guys. That's probably where you guys have to look at the clusters, manage the complexity of these clusters, and be able to hand them over quickly to developers in a flexible way. developers really don't care about Kubernetes, and especially they don't care about the lifecycle management of the Kubernetes clusters. What they do care about are the stacks and layers and application services that runs in the Kubernetes, because their code and the applications that they're building are consuming these dependencies and running on top of them. So where do these complexities come from? So the first dimension, which complicates things, is the different locations or environments where Kubernetes can be deployed, where the underlying infrastructure can be a public cloud, can be a private cloud, data center, bare metal, and even edge. We're seeing lots of interesting use cases with Kubernetes, even at edge now. The other angle of complexity is around the multiple development teams. Large organizations don't just have a single development team, they have multiple. And within those development teams, they might have different diverse projects with different needs. In the end, they all have different requirements in terms of what they want their Kubernetes to look like for their entire stack to look like. The third dimension that complicates things is time. It's easy to design and potentially deploy what we call day zero and day one, but things get increasingly complicated as your business requirements and ultimately your application requirements change over time. So basically, when we're talking about Kubernetes, we're talking about a multi-dimensional kind of Rubik's Cube that makes it very difficult to manage and across these different environments, across these different teams with their unique requirements, and then also the changing business requirements as well too. So how can Cluster API help? Well, let's start off by looking at a typical adoption journey of customers. Most customers start at the experimentation phase, which frequently is initiated by the development teams. But as they move to production, DevOps and IT operations, and in many cases, do take ownership of these clusters. And at that time, look for solutions or products that can help manage these clusters and their life cycles. In the experimentation phase, there is a disconnected experience when it comes to managing the different layers. IT ops or the DevOps engineers would have to manage separately the machines, the operating system, the Kubernetes core layers, as well as the networking storage, and then, of course, manage all of the additional application services that sit on top. Generally, these are facilitated by scripts, which can be very costly to maintain over time, also risk-prone if some kind of change happens in a script that doesn't align with the other layers. And it makes it really impossible and difficult to manage across because of all the different dimensions that we talked about. So basically what Cluster API solves, at least for the core layers, is providing a unified management where the infrastructure, the machines themselves, the operating system, and the Kubernetes layers are all managed as a simple unified experience. Now, just going a little bit deeper into Cluster API, it's one of the most popular Kubernetes orchestration tools. It's governed by the cluster lifecycle SIG. So it's and the amount of vendors that are using it today is just increasing. If you take a look at most modern Kubernetes management platforms, from VMware Tanzu to Google Anthos, even Red Hat OpenShift has an earlier version. And now Rancher, with the latest version of RKE2, is also utilizing Cluster API. They're using it because it provides such a cohesive way of managing the lifecycle of your bare metal, of your machines, whether it's bare metal or public cloud or private cloud, and is able to unify it in a way that makes it simple to even manage the day-to-day management of these machines. So Cluster API is a declarative management system, right? What is the reason for managing the actual Cluster API as code? If you think about it, right, the way you manage your Kubernetes constructs today, like your namespaces, your deployments, your services, RBAC, everything, Kubernetes itself is a declarative system. So the question I have is, why wouldn't you want to manage the lifecycle of your infrastructure, just like even for your Kubernetes clusters, the same way you manage your Kubernetes applications, right? It's simple to read and intuitive. It describes what the desired state needs to be, not how to do it. I mean, just think about how useful it is to be able to describe in a very few lines of code or YAML that I'm deploying a end-to-end Kubernetes cluster on a public cloud. versus doing it on bare metal. The description of how to do it is not specified in the declaration, it's just defining this is the target state that I'm looking for. Not only is it used, this declarative approach used for the initial creation, but it also used to drive your updates and day two management. And in many cases, the recovery is done by just reverting the declarative state to the previous one. So for instance, if you make a modification, it's not a healthy modification, you can easily revert back to the previous state and recover the system. Also, generally with declarative platforms, unless you have data, you don't really need to back up the actual databases, right? What you do is you would just replace the entire declarative state of the system into a brand new cluster, and voila, within minutes, your application should come back fully up and running. So with Cluster API, it does provision multi-master CNCF conformant clusters. And here's, I think the key is that it provisions the underlying cloud cluster primitives, everything from your compute, your storage, and networking. And because it manages the infrastructure, it also provides very advanced resiliency and error recovery capabilities. And of course, like I already mentioned a little bit on some of these day two lifecycle management capabilities, like providing scaling and upgrading, whether it's for your nodes or your pools, and then also helps upgrading your core Kubernetes version. So because Cluster API component is just a typical Kubernetes cluster, right? It uses the same Kubernetes style APIs that we're all used to, the same tooling that we use from kubectl or using GitOps or Flux or Argo CD can be used as is with Cluster API. A little bit about specifically how Cluster API works is it's built around the concept of abstractions, where you define an abstraction or CRD for a cluster, for a machine, for defining how multiple machines are tied together. And then for different cloud environments, for different locations, there are an implementation for these abstractions in something called a provider. So there's a provider for Amazon, for Azure, for Google, for VMware, bare metal, that know how do you take these abstractions like clusters and machines and actually manifest into the specific target cloud. For example, inside of an Amazon cloud, when you are provisioning an EKS cluster, right, it'll provision the EKS control plane, it'll provision the EC2 worker nodes, it'll provision the EBS disks. If you're provisioning inside of a VMware cluster or a VMware environment, it'll just be VMware specific constructs, like deploying the VMs into a compute cluster on a resource pool, leveraging VMDK for the storage disks, and so on. So with that, I was thinking, let's get into a little bit of demo of just how Cluster API makes things really simple. We'll begin by provisioning an EKS cluster, showing the EKS is running, doing some day two operations on top of it, and then showing just how easy it is with the same interface deploying and managing a bare metal cluster. Give me 1 second. Let me go ahead and switch to my terminal. So in my terminal here, I have a kind cluster running on my laptop that has the actual Cluster API components completely running inside of it. You can notice that I have the Cluster API components like the CAPI controller manager. This is the main controller. And for each of the clouds that we will be provisioning into, there is a provider. Here for bare metal, we're using a technology called canonical MAS. You can think of it like a bare metal management interface. And this is where the implementation for Cluster API for MAS resides. And then for Amazon, we're leveraging the Cluster API Amazon provider. If we take a look at what the actual manifest looks like, so we go into the EKS folder here, and I can take a look at this CAPI EKS2.yaml. This is where the actual abstractions and the specific details for how do you provision, or what are the details for an Amazon cluster. So here we're defining a cluster called EKS2. You can define some common properties like what is the actual pod sitter. And then you define that this specific cluster is the Amazon managed control plane. Essentially, this is an EKS cluster. If we were to follow this link, this EKS2 control plane, we notice the details specifically to EKS, which version of EKS to deploy, which region to deploy the cluster in, and for the actual worker nodes, what is the actual SSH key to inject. Then you can define one or more machine pools. These are the actual worker nodes that join in with the cluster. So here we can take a look that we're tying in this EKS2 pool to the same cluster, EKS2. And we're specifying by default, I want to have a desired state of 3 worker nodes. And that the specific details of what else EKS managed node groups need are specified in this EKS pool 0. Here we're specifying that, oh, by the way, that I also want to enable auto-scaling, where you have a minimum size of 1 and a maximum of 5. The default is going to be 3, but obviously as loads come in and out, you can automatically scale between 1 and 5. So what we're going to do next is we're going to go ahead and deploy the actual cluster. So you do kubectl apply -f capi EKS2. You run it. Notice that all of these different resources that you define inside of the capi EKS2 are now created. You can have a really interesting command called clusterctl describe to show what is the actual state of the system itself, right? So at this point, there is a reconciliation loop that is happening where a VPC is going to be created in the next few minutes or so. And once the VPC is created, it's going to start provisioning the control plane, and after the control plane, provision the worker nodes. What I have, because this will take around 15-20 minutes to finish end-to-end, is I have an existing cluster that I provisioned a few minutes ago called capi EKS1. If you take a look at the constructs for this cluster, it's very similarly defined. You know, your pod sitters, your control plane, your machine pools, everything is essentially the same. I can do the same command to look at the details of this cluster. I can say describe cluster EKS1, right? Notice that this case, the cluster is fully up and running in a healthy state and everything is provisioned. They also have a really fancy command to download the kubeconfig directly from the cluster. So I can run that command, the clusterctl get the kubeconfig from EKS1 and save it to a file kubeconfig EKS1. I can run that. And then in another terminal, right, what I can do is I can actually set my kubeconfig environment variable to this file. And then of course, if I can run kubectl get pods, right, this should now be my EKS cluster, right? Notice that everything is up and running. And of course, we can run another application. And of course, the fun one here is Nginx app. And within a few seconds, you'll see obviously a brand new application of Nginx being deployed in the cluster. I also mentioned that with this declarative approach, you get day 2 management capabilities like upgrades and scaling. How easy is that? So if we go back into this capi EKS1.yaml, it's as easy as just specifying a new number for the number of replicas or specifying a new version for the control plane to use. For now, we'll just specify instead of 3 number of workers, let's go to 5 workers. And so here, all we're going to be doing is doing a kubectl apply and save this capi EKS1 back into my management cluster. Notice that none of the cluster abstraction changed, the AWS managed control plane didn't change. The only one that did get modified is the machine pool. And of course, within a few minutes, if I was to run a kubectl get nodes command, right, you would see a brand new node getting added to satisfy the new desired state. So this was more specifically on the EKS portion. Now I'm going to show you in the same management cluster how we can provision a bare metal cluster. So we at Spectro Cloud did open source this cluster API mass provider that makes it as simple to manage your bare metal clusters as it is on a public cloud. If we were to take a look at what the specifications for a mass cluster looks like, right? Again, you start off with the actual cluster definition. This is the common piece of configuration that applies to any cloud. The same pod sitter and service sitters can be specified here, but the infrastructure reference for this cluster is a MAS cluster. On MAS, you specify what is the actual DNS domain name that the clusters bind to. So that is specified in the specific implementation for MAS cluster. This is called MAS SE. And then you define, of course, your MAS machine templates. You know, when you're creating machines, what does the actual structure look like? We're specifying find machines in the canonical bare metal interface that have at least 2 CPUs, at least 4 gigs of memory, are deployed on a specific failure domains using a specific image of Kubernetes. And we can specify the number of workers to deploy. In this case, I'm only deploying a single worker, but notice that it's very similar The kind of specifications are very similar, no matter if you're doing EKS, MAS, or any other cluster technology. So for this one, what we're going to do is we're going to do the exact same operation. We're going to do a kubectl apply F and specify MAS cluster 2. This creates all the various resources. And then we can follow the provisioning state of this one here by running the describe command. And here I can type in my cluster 2, right? Notice that it's already beginning to provision the actual machines on the cluster. And again, with this, we're provisioning a bare metal box, pixie booting it, flashing an Ubuntu operating system on top of it, and then managing the Kubernetes layers sitting completely on top of that. So with that, that's the end of the demo, but feel free if you have any questions regarding the EKS, MAS, or any other provider, ask them in the question sections, please. And let me go back to the actual demo, 1 second, to my PowerPoint presentations. So that was the CAPI demo. Obviously, you saw how it simplified the unification of the bare metal machines, the operating system, and the Kubernetes. But that's not really the end of the story. Is Cluster API enough? So let's take a look at where we left off the complexity. In the early productization phase, where CAPI becomes more and more popular, we're finding that more and more users are, of course, using it. The challenge that IT operations has is that, regardless if they're managing multiple different locations, unique requirement different teams, they have to still manage the complexity that sits on top, which are the application services. This is where we think there is a gap, right? Where Kubernetes declarative management comes in. It should be more about not only managing the machines, the operating system, and the Kubernetes, but also all the application services. So essentially extending that unification of the core layers that includes these layers here, all the way to include the application services that sit on top of it. And this is what we focus on at Spectro Cloud. So we took the concept of Cluster API and essentially built our own orchestration around it, extending to the additional layers sitting on top. We added the day 0, day 1, and day 2 management functionalities to support any operation, especially in day 2, and to support any target environment from your public cloud to private data center or even edge. And now we also do support importing your existing targets in cluster and managing the lifecycle even of those environments. And this is the whole palette, Spectro Cloud palette that we built. What Palette does is it provides you a peace of mind to be able to fully manage your clusters in a declarative approach with all the various layers, with many out-of-the-box day 2 operations from backup restore, RBAC management, and even cost visibility into your clusters. And the way we simplify the management of these clusters is through our concept of what we call the cluster profile. You can think of it like a blueprint or a recipe for provisioning and stamping out multiple different clusters, regardless of which environment they go into, and still using this blueprint for managing the day 1 and day 2 lifecycle of these clusters. With Palette, we also want to make sure that we work with your existing tool sets and tool chains. We don't want to force you to use a specific provider, whether it's Git or CI/CD pipeline. We provide a number of out-of-the-box integrations with Ansible and Terraform. In fact, the Terraform provider that we provide is the #1 downloader provider in the container orchestration category. And we provide a number of out-of-the-box integration choices that span from logging and monitoring and security and service mesh, but we make it really easy for customers to be able to bring in their own tooling, right? Whether to bring in their own Helm charts, or customized, or any of these manifest layers. So with that, please do come talk to us, wherever you are with your cloud native and Kubernetes journey, whether you're starting now or moving your containers into production, and we can help you simplify you manage all your Kubernetes environments. By the way, if you're interested in Palette and what it brings to the table, we are offering free access for the first 5 users who have Kubernetes projects. And then, by the way, if you have any specific questions regarding Kubernetes or Cluster API, me and my team are very happy to help out, with these kind of questions. Feel free to send me an email or tweet at me. My Twitter handle is SAA Mullick. And with that, Patrick, are there any questions for us?
Yes, I could see a few questions in the chat. Just let me check if all of them are actually marked as a question, because some are, I think, just posted in the chat. Okay, I will just start with the last one. Could we make a difference between Palette and Cluster API, or does it distinguish between it?
Yep, absolutely. So let me go ahead and share it one more time for desktop 2. So yeah. So what Palette does is it wraps around Cluster API to provision the application services that sit on top, right? So all the different layers that we talked about, from your logging, your monitoring, your security, are essentially layers that Palette itself helps manage on top of it. On top of that, the capabilities I mentioned, like the day 2 backup restore, the RBAC management, the cost visibility, these are all features that are built into Palette to kind of provide that end-to-end experience. What Cluster API does is provide a unified experience for managing the core layers, right? Being able to provision in any infrastructure environment, from your EKS to your bare metal, managing the operating system itself, and managing the Kubernetes configuration. So that's a distinction, that we sit on top of top of Cluster API to manage the clusters, but then of course Palette provides capabilities on top of that.
Okay, I will just ask all the questions, even though your colleague Pedro already answered some of them quickly, but maybe you can go into depth with that as well.
Sure.
And so for the question was, is there support for EKS upgrade? And your colleague already asked to expand on that question. So it means more the capability to upgrade the Kubernetes version of nodes running on AKS. So that was the precise question elaborated on.
Yeah, absolutely. I mean, this is the portion of the technology Cluster API provides. Not only does it do scaling of your nodes and your different pools, but it does provide the upgrade lifecycle management for the control plane nodes and for the workers. When you're using managed Kubernetes services like EKS, GKE from Google, or AKS from Azure, that upgrade lifecycle is handled by the providers, by the cloud providers, but Cluster API, of course, has hooks into it to invoke the proper API so that it can also upgrade the lifecycle, upgrade the versions of Kubernetes.
Okay, there's a question about the possibility to manage AKS Fargate clusters using CAPI.
Yep, absolutely. So if you take a look, and this is something I can even show in a demo, give me 1 second. So if you want to understand what are the different capabilities, right, that a Cluster API provider is able to implement, I think the best way of looking at it is either documentation, but you can also run the explain command, which looks at what are the fields that are configurable. So let's take a look at this Amazon Managed Machine Pool spec, right? What are the actual fields that you can manage inside of it? So here I'm going to do a kubectl explain into the Managed Machine Pool spec. Notice you can manage things like your AMI type, your AMI versions, availability zones. In here as well, there's the ability to modify and manage your Fargate profile. So you can also attach Fargate, can be managed through Cluster API as well.
Okay, I think there aren't any further questions at this point. Yeah. So yeah, I guess you will be happy, and also your colleague, I guess, to answer any question that still is coming up later, maybe. And yeah, you shared your credentials, I guess, as well, so people can connect with you and ask any questions if they yeah, if they come up with them later, or rewatch the talk later as well. Of course, we will upload it as usual. And yeah, thank you so much, Saad, for joining us today. I'm